Howdy, folks. Yippee-ki-yay. So we left off creating the joints, constraints, the network, so the basic constraint network, and we are left with an object just thrown into this, and we need to, therefore, build the necessary constraint system to make it look pretty cool, like metal. Cool, so let's get into it. What I did, I took the liberty to organize this a little bit more. So let me show you what I did. These really cool backdrops here make it very, very nice to manage this network very well. Basically, if you just select a couple nodes up here and then go up to this box, this little icon up here, and hit create constraint network, creates a nice little backdrop over here, and you can kind of scale it, or if you just select nothing, you can create whatever you want here, and then you can just double click up here and name it I'm awesome, stuff like that. So, and then when you select it, you can whatever's inside, you can manage and move them around. And you can color them too. So actually, I'm just going to color this constraints. Let's color them like something easy in the eyes, like a light purple or dark purple, something like that. Cool. So that's how to do it, and it's nice. Once your network grows, it's extremely valuable for managing. Anyway, let's move forward. Okay, so we have this is our constraint box here, and we got a little collision object collisions here, and the more we build, we can organize this more. But let's jump into making the next set of constraints, which would be our metal bending system. Now, before I move forward, I need to give recognition to a resource that basically allowed me to introduce this Vex code and process into this build. So this is, if you don't already know, OddForcenet. It's a fantastic Houdini resource, mainly forums, and it is unlike any other forum that I've been to. It's really, the people on there are awesome. The community is fantastic, and if you want to learn Houdini, this is the #1 site you should bookmark in terms of a resource to learn. So I just searched metal bend here, and some stuff comes up, but I'll point you to the specific thread that I got this from, and thanks to this dude. This is Sergey. He's Russian, I believe. He brought this up, and where is it? Right here. So this realistic dynamic fracture with bullet. Now there's a ton of responses. There's a ton of examples. What I did was I just went through some explanations, some answers, some questions. I picked apart some of the Houdini files that some of these guys posted. They're fantastic. I do have to give credit to mainly Sergey and where is he? And this guy, Pavel. I believe I grabbed some stuff from his scene that he uploaded. But this guy's pretty good if you want to follow him. Shout out to this guy for being a whiz at this stuff. So anyway, I'll move forward, but just to get that out of the way, I highly recommend that resource. It's fantastic. But back to this. Okay, so let's take the constraints here, the little box. I'm going to move up the unpack to the center here, because we're going to use that as kind of that's going to be our main source to start the constraints, and I'll just throw a null right below it so we know to connect anything outside of this. All right. So first off the bat, let's do a connect adjacent pieces. That's going to be our constraint source. Let's highlight that. And we'll keep it on adjacent pieces from points. Let's bump this bit up. Let's get a little thicker, probably like 0.25 is good. Let's do max search points. It's like 75. And max connections, do like 8. It just multiplies It's kind of like a multiplier. All right. Now the next, let's do a wrangle. Attribute wrangle. All right. This is going to be our defining something like this. So I could just take this wrangle, copy this code. Whoop. And paste it into here. And we're going to rename this to, let's do pin. Okay, so pin will be our main. That will be our basically our bend. I mean, I could name it. You could theoretically name it bend. Yeah, you know what? Let's just do bend. That's more kind of appropriate, straightforward. And remember to change the type to primitives. All right, we'll do another wrangle. All right, this one's going to be part of the important vex that we introduce that allows the constraints to know what it needs to do. So first change this to primitives. Anytime we're dealing with these types of constraints, you always want to change, or we define constraints with this type. All the wrangles need to be changed to primitives. All right, this will be the bad boy. Yep, the bad boy. All right, so I'm going to paste some vex code in here because I already have it. And again, this has been sourced from one of the scene files in this thread. So if you want to browse around that, it's pretty useful. I have that code. So first of all, let me just color this attribute wrangle like something kind of vivid, maybe like orange. All right, let's get my notepad up here. All right, this is the vex code. You always want to keep a nice little handy collection of vex. I'm going to paste it right in here. I'm not going to pretend to explain to know what this is doing exactly, but what I can say out of my experience using it, it's basically defining the position in world space and then referencing it back. It's use another vex later on the dops to reference it back to reposition it in world space as it moves forward with using other different types of force values and whatnot. So, and callbacks and stuff like that. So, all right, moving forward, now we can finish this off by putting a null and name this. This will be con bend. Connect that, and there we go. Smooth this over. All right, so we have that set. We got this constraint. And this is the glue. So let's go back into our .NET. First of all, let's save this. Save as. I'm going to do lesson version 2. Okay, so here we go. If we press play, we got our glue set up. This holds our. This basically creates the integrity, so we don't have to worry about any kind of unnecessary behaviors before something happens to it. All right, we're going to put down another constraint network. Okay. So this is going to be we're going to name this con net bend. All right, let's get a hard constraint. We're going to use that as our main dude. Okay. So we have that. Now we're going to rename this as a pin. All right, let's point to the con bend, accept. So now it's referencing that outside of this, and let's select our glue and go to guide options and uncheck show guide geometry. That is disabling our glue our glue one. Select this, make sure show guide geometry is on, select the hard, go to guide options. Let's just color this, let's do like green. Turn this up so we can see it, like 0.25. All right. Oh, silly me. I named this the wrong name. Bend, not pin. All right, there we go. Now we can see it. So there is our constraints. So if we play this back now, there you go. So it works. Let's reset that. Actually, show guy. Let's turn that back on. See how the glue behaves. Yeah, so this is what we want. As we want to move forward with this, turn this off, just so it speeds it up. Let's turn that off. Yeah, you can see the speed difference. Show guide geometry. All right. All right, that looks good. Let's just test this real quick. Turn off the glue. Yeah, that's what I wanted to get. So you get initially the constraint. So what you do to fix that, select the hard constraint, go to data options. So you get this rest length here. If you put it to 0, this should fix it a little bit. It just sees a value of 1 at rest length. So the second it starts to evaluate, it applies that 1 value to a rest length. Rest meaning, static, nothing happening. But let's just see what happens. So it's got to be 0, essentially. 0 meaning nothing's going on. And play with these two values too. I put the error reducing parameter to 0. And that helped for the initial. So that works. So bring glue back in here. All right. Behavior is better. So that works. Cool. All right. We got that nice and working. Now, let's start introducing the fancy schmancy system. Okay. So what's crazy about Houdini and its parameters and its network system is it seems like it's endless. So what's interesting is in the DOP network, I can hit tab and actually introduce a SOP network, a whole nother SOP network. So it's almost like we're going, it's like an infinite loop. You can make a DOP network in here and go in here, and you just keep going. Like it gets pretty ridiculous. So at the very least, delete that. We're going to make a SOP network. We're going to create SOPs inside the DOPs. Now what that's going to do is just going to allow us to just stay inside the DOPs without having to go outside here. So theoretically, we can make this wherever we want, but the way this guy Igor, he set it up was pretty cool. So I'm gonna do metal bend SOPs. Okay, so now this is going to be kind of the key to where this constraint is then going to reference to then move forward. So go inside here. We're going to need two things, okay? I'm going to need an object merge, 2 object merges, and this is going to be in con. So this is be the constraints. And the next object merge will be the actual objects, so RBD, so that'll be the pipes. So let's just name it RBD. RB. Cool. All right. So this is where it's going to get a little weird. I found it tricky to follow along at first, but here we go. So here's the we need to reference the constraints and reference the objects that we're constraining. So let's start with the constraints. A little more tricky. First, we need to point both of these to the .NET here. So this needs to know that it is referencing objects inside itself or inside the .NET. So /obj system, and we can actually scroll down or just type it in, but just gonna find it here. .NET 1. Okay. So now we have that. I'm going to delete the backspace here and put a colon. So this is going to directly reference an object that I tell to inside the DOP. So if we just go back to the DOPs and we want to reference the constraints, right? I need to grab a source inside the constraint network. So let's select that. You could see down here on our geometry spreadsheet has changed a bit. So it just has a hierarchy of the DOP net, but you can go deep inside of it. We need to get the relationships because that's where the constraints reside. And then need to connet bend. So that's our constraint network we want to control. And we need to get onto constraint network and geometry. So essentially I want to take note of this hierarchy. So it'll be relationships, the constraint network, constraint network, and then geometry. So that's the path I want to use. Let's go back in here. Let's start writing it down. So relationships / connet bend / constraint network / geometry. Cool. So that's what we got for constraints. We have that set. Now we just to do similar to, oh, I put it in the RBD. Let me just cut that, put it in here. Okay, got to do that similar to the RBDs. So we go back, we'll check it out, select our source. We can go down here, source, and all we need is the source and geometry. So it's a little confusing, but we got it anyway. So object system .NET1 and src / geometry. Okay, cool. So we have that set. Now let's build out the rest. So let's start to throw down an attribute wrangle. I'm going to name this to world space. This thing takes a look at where it's at in world space, the actual constraint. Connect this to the first one. Connect the RBD to the second. And let's just get my little handy dandy note of code. We want the second one here. Paste that. Keep this on points. We need another attribute wrangle. And I will provide these, so you can just copy and paste those. I'm gonna copy and paste this guy. Paste that to there. All right, we need one more. Let's take this guy. Let's get another attribute wrangle. Okay, so this guy goes in the first one. The RBDs go in the second. And we'll do null, and this is out. Out con. And paste that right there. All right, let's see if this works. Okay, here we are. Boom, boom, boom. Let's hit play. Boing. So that's what it naturally looks like with normal constraints. And let's just turn these on. Okay, you got the glue and we got the hard constraint. So the glue breaks. The hard constraint kind of bounces. It's very rubbery, bounces right off. So in order to get this thing working, we need to introduce one more thing. Now, if you roll over the third input, you can see down at the bottom here, it says Constraint Solvers. So this needs to solve a problem, which is the logic we have here. So one more little node thingy. It's called the wrong one. SOP solver. Okay, now connect that to the purple guy. Remember to do it on the one that's going to bend. So actually, let me color this to orange. Cool. All right. Since this is its own thing, and we need to point this guy to this guy. So we have an option here called use external SOP. Very handy. I'll just check this solve objects on creation frame so it solves it on the first frame. All right. And I can actually just see you got the SOP path here. Instead of pointing it to this guy using the icon, I can actually take this and drag it right up there. So there's the path. All right, so now this solver is looking at this SOP build. Okay, save it. I'm actually going to save this as version 3. Cool. All right, here's the constraints. Now let's play, see what it does. Well, it still bounces. Now let's just select this, go to simulation, reset. Sometimes you got to give it a little kick. All right, let's play it. Yeah, cool. All right, man, that's working. All right, that's nice. Get some nice bending. Let me just turn off the show guides. So that's cool. And this does kind of require a larger value for it to really see, but we can actually actually see what the value is or get a readout. What's cool is let's get the geometry spreadsheet up like this. We could read it here. We can get what the value is and properly adjust it. But if we move forward, actually, if you just expand this, you get all these properties based on the source, right? Inside the DOPS. Well, what's cool is once we frame forward, once we get hit here, you could see the impacts just showed up. So it's super cool how this thing just automatically introduces these properties that you could see. So I want to find the force value of this impact. So you could just, since you got the rollout, select impacts, and you get this impulse, a bunch of values on this impulse attribute. So if you hit play, you can see this impulse kind of fluctuating like that. So what's cool is I just want to find the maximum here. So let's get about right there. You just click that impulse here. Can you? You can't organize it by that. Not sure why it's not populating it or organizing. Anyway, just scroll down and see what the higher value. You got 20,000. You got 100,000, 80,000, 400,000 ish. So we're looking around 500,000, right? So I'd say 444,000. That is the impulse value. All right, so you can see the impacts, the impulse. Yeah. Let's just see that real quick. 400,000. All right, let's go back in the year. I'm going to put it just above. So let's do like 440,000 because I want some of them to get really affected by the bend and then the others to kind of take the hit and react a bit and bounce so they don't just all look like clay. Let's reset this sim here. Select the source. I just kind of check something that's time dependent and resolves that. There you go. All right, that looks pretty cool. Let's make some let's move the collision object down a bit. and make it bigger. Let's do like 10. And let's just add some topology. Go up to polygon mesh. Axis, let's do 10, 10, 10. Let's make a mountain. Let's make this thing more interesting. Oh, wait, let's put it up here first. There we go. Woo woo, all right. That looks good. Go back and dot. Here, just check the, let's do concave. There we go. Cool. All right, and let's take the collision object. I'm going to up the density like 5,000. See this thing really kick this stuff's ass. Boom. That's a lot. And let's bump it back down to like 1,500. It's not bad. I kind of want to move this thing over a bit so it's not going right into it. Cool. The thing is, though, these things will not break. The constraints won't break, so I'm going to add in a rule that says it tells it to break. Okay, since we have, and we need to input it into the solver, so since we already have the solver in here, we just need a merge. Throw that in here. We need another SOP solver to tell it when to break. Okay, go inside here. We need the relationship geometry and an attribute wrangle. And since our primitive, our constraints are primitives, we gotta do the run over to primitives. All right, let's make a condition. Okay, if the distance, whoops, to all caps. So if the distance, so there's like torque, there's force, there's a couple different attributes or variables we can apply this to, but I like to use distance. It's kind of the, I don't know, I found it to be the most effective in situations like this. So we're going to do at distance. And actually, we have to define that, call it out. So that's going to be a float. The distance is a float value. Is greater than, let's see, greater than channel. Well, channel quote. We're going to call this break. Break me. Quote and parentheses and another end parentheses. I'm going to do open curly bracket, enter, and then that's if the distance is greater than this. If you just hit this icon here, it'll read the channel expression and throw a value down here, or a slider. So if the distance is greater than this value, then, which is open curly bracket, tab, remove prim 0 comma at primnum comma 0 and parentheses semicolon and curly brackets. Enter, and that should be boop, done. So this is the value, and let's just do like, it's like 0.5. All right, see if that works. It has seemed to work. So you can see, I'll show you how the behavior is really cool. since we want to make the value here just right under the maximum impact force value that it hits. And you can play around with that just so you can see the behavior of some of the stuff that isn't broken. Like this guy here, he kind of wiggles back and forth. Now, if I lower this, if I just get rid of a 0, it's going to activate this whole system fully, and it will reposition itself and hold it there, almost like it's putty. So if I just go up here, select this. This is how I reset this DOP network, by the way. I just check and uncheck a time-dependent value. So let's play it again, see what it does. Ooh, let's do that again. Okay, it might be a little hard to tell with this one, but I can kind of see it. Yeah, it all kind of just smushes together, smushes out of the way. So I'm gonna go back in here, add another 0. So I like this. I like this value, but it might be breaking a little bit too easy. So let's put like a 1 here. That's a little better. Well, I kind of liked it when it broke everything. But this guy might be too heavy, so let's do like 700. And let's take the glue, probably raise that up just a bit to like 3. That's cool. Let's see what that looks like. All right. That's pretty nice. That's nice. This is nice. Cool. All right, so next up is wood. I'm going to add the wood in here. We're back out. Let's do just copy and paste. Keep the colors and everything. Name this input wood. Cool. Let's change this name real quick over here to input out wood. Let it fracture a bit. There it is. So there is our wood. Now, one thing I forgot to do is I wanted to cluster these fragments. So let's go back into prep. Let's go to the wood here. Okay, well, just select this one here. Make sure you got the flat shaded or smooth shaded. Either one. Select the Voronoi, go to visualize pieces and cluster. Select the cluster pieces. All right, size. Let's first copy parameter. No, copy parameter here. Paste relative. Well, let's switch it to manual. Do that again. Paste relative. That way I can update this guy here, and these two will update. All right. So auto update. Let's see what this looks like. Let's change this to 0.1. Let's actually do like 0.75. All right, random detachment. Detach ratio of like 0.5, 0.8, I think. Make the size bigger. Let's do like 3.5. And detach ratio, let's just go back down to 3.5. This is just, getting the right values in. That looks better. See, some of these are starting to, let's do like 0.15. Yeah, I like this. See how you got these all solid pieces here. This looks pretty good. Change the seed a bit. Yeah, all right, let's just 0.175 just so I'm happy. That is cool. I like that. All right. Turn off visualize pieces, and here we go. Let's go back into system. Here's our wood. All right. Let's assemble. We need to assemble this thing. And name this the prefix wood and create pack geometry. Don't have to transfer anything, I don't think. No. Yeah. Same here. We're going to apply, just kind of copy and paste this. Make sure it's active. And move this guy over here. We're going to make some constraints. We'll keep it in this box as well. Put a null down so we know that this is kind of the end of the line for prepping this. All right, make sure you get the active as 1 down here at the spreadsheet. Okay, let's save it. Let's move that up a bit here. All right, unpack. Not Unix. Unpack. Put this bad boy here. And make another null here. So this is going to be our out wood. Okay. We just split this up, go to unpack, and what do we have? Just transfer active and path. Just, I won't really need this, but just I like to be consistent. All right, let's make some simple connect adjacent pieces. It's going to be pretty simple, straightforward, nothing too complex. Definitely nothing as close to the bending constraint stuff. So, all right, we'll just keep it simple. Adjacent pieces from surface points. Let's highlight this. It looks pretty good. Just needs to be rough. Nothing too crazy. All right, we need an attribute wrangle. So again, make sure it's primitives because the constraints are primitives. All right, so S for string call out constraint underscore, it's the name, equals to quote wood, and S call out constraint, and the type is equal to, this is a position. We're defining it as a position. Cool. Oh, why is it yelling at me? Oh, needs semicolons. I always forget that. All right. Oh. Cool. So we got that. Null to cap it off. We should be good. Con wood. All right. Nice little managed, organized. Let me just hit Control B to maximize this. Cool. So we got our wood. Got our constraints for the wood, constraints for the glue constraints for the metal bars, and the bend constraints. Over here we got our collision, and here's our dot network right here. Actually, so let me just select this, click this little icon, and we have a nice highlighted box, and this will be dot. There we go. Just to make it nice and there, cool. Colorful. Control B, go back out of maximizing. All right, let's go into DOPS and bring the wood in real quick, okay? So we got our source, collision object. Collision object is, let's color this. I like to do green. Source will be blue. All right. I'm going to copy and paste this bad boy. Rename this to wood. Connect it in there. And keep everything on. Don't have to inherit anything. Bullet data. We just need to do a second. Do I want to input that in there? Yeah, why not? Okay. Let's move the constraints over and move this here. Just going to input the wood into the second input there. Okay. Create a second, make sure it's second context, geometry. Boom. Look at that. Okay, now I need to connect the constraints real quick. So the cool thing I love about the DOP network and the constraint network is you can layer them like a mofo. I think if I hit Shift L, no, that realigns. Yeah, Shift S, you can change the wire layout. I like to keep it kind of freehand like this. All right, let's add our constraint network. So constraint network, plop it right in here. Okay, for debugging, I'm just going to turn off the source. I'm going to turn off these guys. And just like the other ones, I'm going to move this down a bit. Select all these guys, and there we go. Make another box, just so I know that these are all the constraints. Constraints. I like to be clean and neat. There we go. All right. Just color this like dark here. There. Cool. Let's make glue. I don't need anything fancy, just the glue. This is wood here. And let's do the glue for like, I think it's, was that 1,000,000? Let's see if this works here. So, show guide geometry, okay, and let's see if that works. Nope, it doesn't because I'm an idiot. We gotta point the constraint network to the con wood. Look at that, nice and organized, guys. It's fantastic. All right, did it do it? Did it do it? Turn this off real quick. No, oh no, geez. See, I'm screwing up, guys. I'm terrible. This is ridiculous. Rename it to wood. There we go. Let me just, yeah. If I just hide if I go up to the wood here and I turn off display geometry, you can see the joints or the constraints. There we go. Yeah. All right, before I go further, let's just double check the guide geometry, make sure it's convex hull or concave. No, not convex hull. That's too much. Ooh. Concave. Create convex hull per set of connected primitives. That takes into account if it's all one solid object, but it has multiple pieces involved. It'll not create an entire convex hull around it. It will make it per object. So that looks good. Turn that off, display geometry, and let's just test this out. Save. That's cool. Might be breaking a little too much. So I'm gonna put one more 0 on here, and I think that's like 10 million. That's getting there. Let's do like 8 million. Crazy numbers. That's cool. That's better. Maybe not that far. Let's do like 4. All right, let's turn back on the source. Turn on the glue for the source, which holds everything together so it does nothing moves. And turn on the bend. All right, let's select one of these. I'm just gonna reset the sim. Selecting this is what I usually check and uncheck. Hit play. This is looking cool. Boom, awesome, freaking cool. Wood's breaking a little bit too much, I think. but I'm going to leave it for now. No, I'm not. Just kidding. Let's raise this up to like 6. And one other thing I noticed is that, yes, this is looking cool. It's bending appropriately. The wood's shattering. The dynamics look pretty good. But the whole rest of the cage or the rest of the structure is not even budging. So I think the glue for this guy is a little too strong. So let me just show this. Yeah, see, it's like all this should kind of start to give away. And we can come up with these cool, I have this, I can come up with these cool like activation scatter particles that move along here that based on velocity and stuff. But we're not going to get that complex just yet. This is pretty basic. So let's turn this down to like 1. Let's go back, save it. See, I want the upper one to be affected a little bit less. So let's just turn this to 6, and this is like 3. Put this to 1. You just want to change this until it's just right. Just start playing with it. There we go. That's better. Might be a little too much though. So that's cool, but the bars don't break. I think they don't break enough. I need to go back in here. Let's just rename this to break. All right, break me. Let's do like 0.5. This is looking all right, but it's getting a little too weird, bendy. It's not exactly the bending that I want. So just for the sake of it, I'm going to go back in here, turn this down real low. See how this looks. This is better because, the rebar doesn't necessarily all stick together. There is definitely some loose fittings, but yeah, that's a little bit better. I think I can up that just a bit more. Let's do like 0.18. No, still not. Almost there, guys. Almost there. Let's do 0.1. Let's do 0.1. Looks kind of cool. Looks cool, but it's not. Yeah. Let's strengthen the glue a little bit more. It does look kind of cool, though. Look at that. All right. Gonna tighten this glue up right here. Let's do 7. That's better. Yeah, I'll keep it to something like that. Turn up the braking. It's 2.15. And one more thing is let's move up. Uno más. Let's hit this pink guy here so I can see it. And the transform. I'm going to move this up a bit. I want this thing to hit like the top of it. There you go. Let's see how that looks. Bam. That's cool. I think that might be good? What do you guys think? I think I can raise this up a bit. Let's do 4, 5. Reset. And let's turn up this a bit more, 0.18, and I think this might be good. I'm gonna keep this one. This is cool. Just turn the viewing the glue off. Bam, that's cool. And also, I think I changed my substeps to 4. So if I go to 2, nothing. So it's a pretty big difference. Let me do 3. Ooh, I like that one. Yeah, I like 3 substeps. That's awesome. That works. That works for me, guys. Cool. So we got the wood in there. We have a nice behaving metal bending. You can see that kind of wobbling like that. That's really cool. Let's play this back. Bam. Sexy. All right. And you can play with this however much you want. Start throwing in some different collision objects. And also, you can even have more fun with it. You know what? I'm going to... Yeah, let's do this. Okay, so remember when we are activating our guy down here, if I just bypass this, so now the whole thing is active, right? So I just go like this. Yeah, the whole thing's active. Let's see what that looks like. That's cool. Let's see what this looks like. That's awesome. That's cool, guys. And you know, if you wanted to, you could even constrain the wood to the metal bar source. So, but since, you know, if you could just see, these are just laid on there. So everything works appropriately. All right, so I'm going to re-bypass this. So now I have a base anchored down nicely. And I'm going to cache this out. But first, I need a DOP, the DOP import. And this needs to read that. So you just drag the DOP network into this. So it grabs the path. Just like this. Object mask, I need to change this. Fetch, yep, change it to fetch geometry from DOP network. And object mask, it's just looking for all the objects. So I can actually go in. We just need collision object, source, and wood. So I think I can just go collision object, space, source, and wood. All right. So I'm going to cache this bad boy out. Let's do cache, file cache. Pump it in there. You know, it just saves it into the directory where you have the scene files. And boom. Make sure you load from disk and you do save frame range. Yeah, it's already there. And there we go. 1, 2, let's shift, control shift click this. Let's just do 125. I don't need the whole thing here. Save to disk. All right. Okay, guys, check this out. This is cool. So what I did was I actually went back in. This is cool. I actually went back into the DOPS and I didn't realize I forgot to turn down the density for the wood. The wood was the same density as the bars or the source, so it was it's kind of weighing it down, so giving it some irregular behavior. So I just turned it down to about 250 since these planks are relatively light. So yeah, that was it. This is it. Boom. I think I love this one. I could work off this, just the way it rips off the chunk of hair. These things are kind of bouncing around. Yeah, I like this. This is pretty gnarly. This is cool. Nice. All right, so I think we got our system here all set. Here's our cache. It's all cached. Bam. Cool. Okay, let's just package this up, put a null, and this is just going to be out. All right. So, thanks for watching, guys. This is probably one of my favorite systems to build. It's just really robust, and you can kind of implement this into a lot of different structures, and it's pretty stable. But thanks again to Pavel. This dude came up with the wonderful, the wonderful Vex right here. Kind of holds this all together with the help of probably a bunch of other guys within the forum, but in OddForce. But thank you to Pavel and OddForce for allowing me to show you how I can resource that and bring it into a system that I can modify and do whatever I want. So here you go. Cool, guys. Thanks for watching. I hope this helps. I'll see you guys next time. Peace.